Good morning or good afternoon to our students in 034. This is Miss Manley, and today I'm going to be starting Unit 1 over functions with you. Our success criteria that we are looking at today is, can we tell if a relation is a function or not a function? Can we identify linear graphs, quadratic graphs, and exponential graphs? And can I identify key characteristics of graphs? So some of this is going to be review and some of it's going to be new. If you have your math notebook with you, you do want to go ahead and take that out today because you are going to be taking some notes. If you don't have your notebook, there should be some notebook paper in the classroom that you can use for today. But again, you do need to get a notebook. The first thing I want to do is just review the definition of a function with you. So a function is a relation between a given set of elements such that for each element in the domain, there exists exactly one element in the range. Functions are one-to-one. Okay, for each input or x value, you can only have one output or y value. A relation is just a collection of ordered pairs, a table of numbers, a mapping diagram, a graph that have a relationship to each other. So all tables are relations, all graphs are relations, all ordered pairs are relations, all mapping diagrams are relations, but they're not always a function. So in middle school, they would just usually say, is it a function or not a function? What we're saying to you now is the relation a function or not a function? So a few things to remember from middle school. So if you have a notebook or notebook paper, I want you to copy this down into your notes. So title it, is the relation a function? And then you're just going to copy these first two little bullet points here. X cannot repeat, but I want you to add X cannot repeat with a different Y. X cannot repeat with a different Y. X can repeat with the same Y, just not a different one. And then the vertical line test, which we use only on graphs. So if you've forgotten about the vertical line test, with the vertical line test, we just draw a vertical line. I know mine's not very vertical, but we'll just pretend. We draw a vertical line, and if it's only touching in one spot, it's a function. However, if we'd had a graph like, let's see if I can think of one that I could draw for you. I have to change colors. It's not letting me draw there. There we go. If this was my graph, it would not pass the vertical line test because it touches in two spots, which means those x values are repeating. When we're looking at relations to determine if they're a function or not a function, we're still going to be looking at the same representations that you've looked at in the past. Sometimes it's going to be sets of ordered pairs, sometimes it's going to be a table, sometimes it's going to be a mapping diagram, and sometimes it's going to be a graph. So let's first of all just do some review with ordered pairs. Is it a function? So you don't need to copy this down. You can just kind of answer this to yourself, or if you have a dry erase board and you want to answer it on there, that's fine too. So when we're looking at ordered pairs, you just need to determine that each x value has only one y value. So go ahead and take a moment to look over 1 and 2, and then we'll go over the answers. All right, so if we look at number 1, we have 0, 2, 3, 4, negative 3, negative 2, and 2, 4. So we can see that when we look at our x values, we have 0, 3, negative 3, and 2. Since none of those x values repeat, this one is a function. Now let's look at number 2. With number 2, our x's are 0, 2, 0, and 4. The first thing I notice is I have 2 zeros for x values, so I need to check their y's. If the y's are different, this is not a function. So I have a 1 and a 3, so that means the input 0 has 2 outputs, and this one is not a function. All right, let's look at tables next. So again, I want you to take a couple moments to look over these 2 tables, check those x values, and decide, is it a function or is it not a function? So when I look at the first table, and I'm going to concentrate on my x values, I have a 2, a -2, a 3, and a 2. So again, I need to take a closer look at those 2's. So I have 2 with the output of 1, and again 2 with the output of 1. This is still a function. This is still a function because the definition of a function says the input, my x value, cannot have more than one output. This one doesn't have more than one. It's the same. Okay, 1 and 1 are the same. It's okay for the full x and y to repeat. It's not okay if the 2 was with 2 different numbers. I often tell my students to think about it like dating, like relationships. So you can think of it as 2 and 1 are dating. So 2 and 1 are dating, they break up, they get back together again, they're still the same couple. But if 2 was dating 1 and 2 was dating 0, that would not be a functioning couple. You would probably need to break up, and it's not a function. Number 2, we have 1, 2, -2, and 3. Since none of my inputs repeat, I know this is a function. All right, let's look at some mapping diagrams next. I want you to remember that when you look at a mapping diagram, you need to look at how many arrows are coming out of your inputs. Okay, so in this first one, 2 is going to 20, which would be 2, 20, and 2 is going to 40, 2, 40, which would mean this is not a function. So now you do the same with number 2. If you said that number 2 is a function, you are correct. Each of my inputs, -1, 0, 1, 2, and 3, do not repeat, and they're only connected to one output. The last representation that we're going to review are graphs. Remember, with graphs, you need to do the vertical line test. Okay, the vertical line test. So I'm going to give you about 30 seconds to look over these 3 graphs and decide, is it a function or not? And then I'll go over the answers. All right, here we go. For number 1, you can see that if I was to draw a vertical line here, it would touch it in 2 different places, so this is not a function. This is a function. This line is linear, therefore it's only going to touch 1 time. Number 3 is the tricky one that most people get messed up on. If you put a vertical line on top of another vertical line, it's touching it in infinitely many places. It's touching it everywhere, so it is not a function. So number 1 was no, number 2 was yes, number 3, no. All right, take 30 seconds to look at 3 more graphs. right, with our next three graphs, number one is a function. If you draw a vertical line through here, it's only going to be touching, it's only going to be touching in one place at a time. Okay, one place at a time. Number two is not a function. Anything in the circle or oval family is not going to be a function because it's going to hit it in more than one spot. And then number three is what we call a discrete graph, which we'll learn about today. Discrete just means it's dotted. Those points are not connected. So when you do your vertical line test, you have to do it for each one. And each time I'm only touching one point. So this is a function. Now, if I had a point here, it would not be a function because it would touch in two places. All right, so I want you to quickly review the four representations of functions that we just looked at. So what I'd like you to do now is pause your screen until you have answered these four questions, and then unpause so that you can see the answers. So for number one, again, we're going to focus on our x values. So I have 1, -2, -1, and 1. So I have 1 with -2 and 1 with 3. This is not a function. Number two, this would pass the vertical line test. So number two, yes, it is a function. Number three, my inputs are 10, 20, 30, 40. Those do not repeat. So yes, this is a function. And number four, my inputs are 3, 4, 5, 4, and 10. So I've got two 4s, so I need to double check it. 4 does have two outputs, 7 and 14. So no, this is not a function. So hopefully that first section was a review for you from middle school. And now we're going to add a little more into our functions. So what I would like you to do is on the first page of your notebook, go ahead and draw this chart. You can turn your notebook sideways, you can leave it vertical, however you want to do it because it's your notebook. But you need 3 rows and 4 columns. So you're going to label the first column function, the second column description, the third column graph, and the fourth column equation. Pause the screen now to go ahead and create your graph, and then your table, and we're going to fill it in with the 3 types of functions you must be able to recognize in 9th grade. All right, here we go. The first type of function you're responsible for knowing in 9th grade is a review of 8th grade. In middle school, the only type of functions you worked with were linear functions. So in your first box where it says function, you're going to write linear. In the second box where it says description, so you're going to write going across. Each row is a different function, so each time you're going to move to the right. So in your first box, you write linear, move to the right, and under the description, you're going to copy down straight line that is increasing, decreasing, or constant, and y equals mx plus b. Feel free to abbreviate anything that you need to. If you can put INC period for increasing and DEC for decreasing and you know what it means, that's perfectly fine. Once you've copied the description, you're going to move right again to the graph box. And in the graph box, you're just going to sketch examples of linear graphs. Okay? The top one is an example of a graph that is linear. The bottom one is an example that is nonlinear. And notice I'm saying sketch. It does not have to be perfect. For your linear graph, you could just draw a line like this. For nonlinear, or not a function rather, you could just draw a vertical line. Then you're going to move to the right one more time into your last box where it says equation, and you're going to copy these 3 equation types. Y equals 2x plus 1, where I have a slope of 2 and a y-intercept of 1. Y equals 3x, where I have a slope of 3, and that means my y-intercept would be 0, so it's going through the origin. and y equals 2, which creates a horizontal constant line. So again, go ahead and pause the screen at any time to get your notes copied. So if you're not finished, pause now, and then unpause to continue. You're going to move down to your second row, and we're back in the first box where it says function. You're going to write the word quadratic. Quadratic. For your description, a quadratic function is a parabola. Parabola. That makes a U shape, so you may want to put U shape in parentheses. You also need to note that it can be upside down. So this right here is a regular parabola. This one is an upside down parabola. The equation that we use for quadratics is y equals ax squared plus bx plus c. Move right again to your graph box and sketch examples of both kinds of parabolas here. And you may also want to sketch an example of a not a function. This one is still a quadratic, but it's not a function because when you turn that parabola sideways, it doesn't pass that vertical line test anymore. Once you're ready to move on to your last box, these are your equation examples. Y equals x squared and y equals 2x squared plus 4x plus 1. You need to be able to identify these functions by looking at a graph or by looking at their equation, or if I were to just give you a description. The easiest way to remember quadratics is quadratic starts with the prefix quad, which means 4. And if we ask ourselves what shape has 4 equal sides, that's a square. All quadratic equations are squared. So they're always going to have that exponent of 2. Again, go ahead and pause the video now to go ahead and complete this second row, and then unpause when you're ready to move on to the third row. All right, your final function type that you need to know is an exponential function. Exponential. So for your description, it's a curved line that's either increasing or decreasing. And we use the equation y equals ab to the x power. Y equals ab to the x power. And I apologize if any of that's cut off. So again, that says curved line, increasing or decreasing, y equals ab to the x power. When you move to the right for your graph, you're going to sketch both the increasing and decreasing exponential graph. And for your equation examples, this one should say y equals 3 to the x power and y equals 2 times 4 to the x power. Again, some of the things are getting cut off as I'm recording my screen, so I'm just going to try to make sure I pay attention and let you guys know. Quadratics and exponentials are the two that students most often mix up because they both involve exponents. But what you should notice is that exponential, it's exponential, the exponent is x. So just think of the x's. Exponential exponent x. Exponential exponent x. When you have finished filling out your chart, you're going to use it to answer questions on the next couple of screens. And again, since you're just doing this on the computer, you're welcome to just answer these in your head and then hit play again when you're ready to see the answer. All right, so go ahead and think to yourself, what type of graph is represented? You're welcome to use your notes because I don't expect you to have them memorized yet. But if you want to try without your notes and then look at them, that's fine too. Whenever you're ready, go ahead and unpause the screen to see the answers. So this first graph was quadratic. I'm just going to write quad. Second was linear. And the third one was exponential. All right, let's try looking at equations now. So again, go ahead and pause your screen while you decide what type of functions you're looking at, and unpause when you're ready to see the answers. So for number 1, that one is linear. Number 2, quadratic. And number 3, exponential. Again, think of it as exponential. Your exponent is x. All right, now we're ready to go into the next section of functions. So far, we've discussed if a relation is a function or not a function, which was review. And we've discussed the 3 functions that we need to know in 9th grade: linear, exponential, and quadratic. The next thing that we're going to do is talk about the key characteristics that we need to identify when we're looking at graphs. And those graphs might be linear, they might be quadratic, they might be exponential, they might be a type of graph that we haven't learned. So in that case, you don't need to know the name type. So in your notes below where you put your chart, I want you to skip a line and title it Characteristics Checklist. And then copy down this characteristics checklist here. So you need to know whether a graph is increasing, decreasing, or it could actually be both. You need to know if a graph is continuous or discrete. You need to know if it has a maximum, minimum, or neither. You need to be able to identify the x and y intercepts. And if it's a linear, quadratic, or exponential function, you need to identify what kind of function it is. Now, as we go on to these next few screens, there is some information about these key characteristics that you may want to write in your notebook. Okay? If it doesn't specifically say notes, you're not required to write it down. But if it's something that you think would be good to write down to help you remember, then please make sure you write it down. So again, if you're not finished copying down the characteristics checklist, I want you to go ahead and hit pause now so that you can get it copied. And then when you're ready, hit play to go to the next screen. All right, so the first thing that we're going to talk about is increasing versus decreasing. There should be a V right there for versus. Increasing versus decreasing. Versus. All right, so you guys have looked at linear graphs in the past and you've talked about slope. So positive slope, such as in this first example here, would be increasing. We can see that this is going up, so it's increasing. If I had to walk on it, I would be walking up the mountain, so it's increasing. Whereas down here, I would be walking downhill or sliding downhill. So this one is decreasing. With your exponential graphs, you can still look at it the same way. For most of you, you'll be able to just look at it and say, oh, that's increasing, or oh, that's decreasing. If you can't, draw a line from end to end, so then you can see, oh, this is positive slope, so that's increasing. Or draw one from end to end here, oh, that looks like negative slope, so it's decreasing. I don't have an example on here, but I'm going to draw one of a quadratic. A quadratic graph is doing both. So I'm decreasing and then increasing. So it can be both. Our next key characteristic, and this is one that you might want to write in your notes, is continuous versus discrete. So when you see the word continuous, I want you to think of the word connected. Continuous graphs are connected. So these normal types of graphs that we usually see, these are continuous graphs. Every single number that's on this graph, every single number on this blue line is a part of it. Every single number on this wavy graph is a part of it. Same thing down here. Every number contained is a part of it. The opposite of that is a discrete graph. So with discrete, think dotted. Discrete graphs do not include the numbers between the dots. So for example, in this one right here, these are the only points included. The space in between is not included. We don't connect it, we leave it as is. It's discrete. If you need to write that down, feel free to hit pause before going to the next screen. All right, up next is maximum versus minimum, or it could also be a none. Okay, there are cases when it doesn't have a maximum or a minimum. So your maximum is your highest point, okay, the highest point on a graph. So these two examples on the left have maximums. This is the highest I can go on this graph. This is the highest I can go on this graph. Sometimes we might just ask you, does it have a maximum or a minimum? And you would say yes, maximum, or no, minimum, or both, whatever it may be. And then sometimes we may ask you, what is the maximum? What is the minimum? So if I asked you what is the maximum here, you would say, oh, it's 3. Or, oh, it's 2. For a minimum, the minimum is the lowest point on a graph. We can't go any lower than this point, which is 0. We can't go any lower than this point, which is at 2. So maximum is the highest point. Think of it like the peak, the mountaintop. Minimum is the lowest point, the lowest point. Your next key characteristic are your x and y intercepts. So I know that in middle school you did a lot with y-intercepts, but you also have x-intercepts. So again, if you need to add this into your notes, feel free. Your x-intercept is where the graph crosses the x-axis. So in case you've forgotten, your x-axis runs horizontally. And I highlight it in yellow. And your y-axis runs vertically. I'm going to highlight it in blue. So in this first graph, if I asked you what your x-intercepts are, you're going to look at the x-axis and you're going to say, oh, it's touching right here at -2, and it's also touching at 4. So you would just write -2, 4. Don't write it as an ordered pair. Do not write it as an ordered pair, because -2, 4 is a point way up here. It's not these 2 points. So again, it's just -2, 4. If I ask you what are the y-intercepts, I'm going to look up and down my y-axis and see, oh, there's a point right here at 2. So my y-intercept is 2. Same thing over here on the right. X-intercepts, I have one right here at -3 and another one here at 2. So notice you can have more than one. For my y, I only have one, and it's right here at -6. So when we ask you about those x-intercepts and y-intercepts, we want you to tell us what the numbers are. What points are they at? And again, if at any time you need to pause the screen or go backward, feel free to do so. All right, so let's look at some examples. So you're going to look at this picture of a quadratic graph to the right, And you're going to tell me, is it discrete or is it continuous? What are the x-intercepts? What are the y-intercepts? Is it increasing, decreasing, or both? Does it have a maximum? Does it have a minimum, or neither? And is it a function, yes or no? So I want you to go ahead and pause your screen and either answer these in your head or on a sheet of paper, and unpause when you're ready to see the answers. All right, so this graph is connected, so it's continuous. My x-intercepts are at -1 and 2. My y-intercept is at -2. I am both decreasing and increasing because I'm going down and then up. It has a minimum. We could estimate that minimum. It's at about, -2.2. But for now, we're just saying it does have one. And is it a function? Yes, it's a quadratic function. All right, example 2. We're going to do the same thing. So pause the screen. Go ahead and answer your list of characteristics, and then unpause when you're ready to see the answer. All right, so this is an absolute value function. You don't need to know that for a test. I'm just telling you that's what it is. So in this absolute value function, it is continuous because it's all connected. My x-intercepts are at about -3 and 1.5. My y-intercept, we're going to estimate it's at about 3.1. Is it increasing, decreasing, or both? It's both. It's going up and down. Does it have a maximum, minimum, or neither? It has a maximum, and that maximum is at 5. And is it a function? Yes. This would pass the vertical line test. Couple more examples, and then you guys are going to work on some practice on Delta Math. All right, example 3. Same thing. Go ahead and pause the screen and answer the questions about this graph, and then unpause when you're ready. All right. This is a discrete graph. Discrete because these are dots, or technically they're points, but it looks like dots that are not connected. X-intercept, so if I go to my x-axis, my point is right here at the origin, so my x-intercept is 0. Y-intercept, same thing, it's at the origin, so it's 0. Increasing, decreasing, or both, this is increasing. Maximum, minimum, or neither. For this one, from the snapshot that we can see, the maximum looks to be this point and the minimum looks to be this point. But since we can't see a full snapshot of the graph or a full shot of the graph, we can't say for sure. So I'm just going to say neither. We're just going to go with neither on this one. And then is it a function? Yes, it is. All right. Example 4, same thing. Go ahead and pause the screen to answer the question and unpause when you're ready. This one is multiple choice. So which characteristics best describe the graph to the right? So for this one, I would use process of elimination. Right off the bat, I can see that this is not connected, so it's going to be discrete. So B says continuous, so it's out. D says continuous, so it's out. So they both say discrete. So now the only other thing is one has an absolute minimum, and one has an absolute maximum. This is the highest point, So it has a maximum, so it is C. This is a function, it is discrete, and it has an absolute maximum. All right, we're not going to do an exit ticket today because you guys kind of did a lot of work yourself on this video. So what you're going to do next, if you need to go back and re-listen to any of the video again, please feel free to do so. But once you're finished with the video, you need to log into Delta Math, and you're going to have some function practice activities to complete. And then, of course, if you're not finished with your LHS Mastery homework, you need to work on that as well. If you were not here on Monday and Tuesday when we set up our Delta Math accounts, I am leaving instructions with Miss Pineda, and she can give you the instructions page so that you can get your account set up properly. If you guys have any questions or concerns, remember you can come see me, Miss Manley. I'm in 030. You can go see Coach R. He's next door to you in 032. Or you can see Miss Harris at the top of the hall in 018. Hope you guys have a great rest of your day.